Welcome, everyone. So I would like to talk about my research on local first peer-to-peer collaboration. So my background, I don't have to say it again. In my talk, I would like to touch on the following post-web principles that I believe were introduced before, in particularly local first, privacy security, sovereign cryptographic identifiers, efficiency, scalability, and resilience, and plurality with interoperability. That all of these I analyzed in my research, and in this talk I would like to share some insights and important things I found out that I would like to share. So now I'm just going to briefly go over these principles, what they mean and what's important about them. When designing networks, we should allow end-to-end security of data and messages traversing the network. Minimize data exposure to intermediaries when we route messages through many hops. Important also control the data locality and the possibility of data deletion, especially for private sensitive data. For public data, you don't care about them, but when we collaborate on private data in private groups, this becomes important. And also location privacy becomes important. You might, in a traditional peer-to-peer network where you talk to many nodes, this is not given since your IP address is publicly visible. In terms of sovereign cryptographic identifiers, these are used to allow pseudonymous interaction in the network, public key identifiers for users, groups, and mutable data repositories. In terms of efficiency, scalability, and resilience, we want the network to scale in terms of users, groups, data, and we want to allow also clients with low resources, mobile clients, for example, to participate in the network without draining their batteries. And we want the network to be resilient to attacks and censorship, as were explained in the previous talk. In terms of plurality, the network might consist of many different subnetworks and protocols, but we want them to be interoperable in some ways on the network and data layer. So on the network layer, this might be possible with using several sovereign peer-to-peer sub-overlays or domains, and allowing requests to these also from external sources for the public portion they want to expose. And on the data layer, this might be possible through standardized data types and formats, such as what the existing web standards allow, also for social media and semantic web standards exist for describing common data types and for sharing on the networks, such as activity streams that ActivityPub uses and semantic web ontologies. And when it comes to local first, this becomes important, so we can do local aggregation and search of locally stored data that is available locally from multiple sources, such as when you have events in a calendar from multiple sources, you can aggregate these and search for these, but only if we can agree on a common standard how the data is represented, even if they are posted in different groups and networks. And now I would like to talk about local first. And this is what I've been working on in terms of the Lo-Fi project. That just briefly introduce this as it's an end-to-end encrypted data store that allows collaboration between members in a private peer-to-peer overlay. And such collaborative data stores are the basis for group collaboration for many purposes. When we look at DAOs that are taking off these days, what is missing from this space is to have also private and secure collaboration tools, and having such private and encrypted data stores that allow coordination and collaboration within group members of an organization or an informal group becomes quite relevant, because currently only centralized tools are available for this that are commonly used. Some upcoming tools are available, but the usability is not great yet, so hence this research is quite relevant. So these data repositories allow membership and access control, cryptographic authentication of data and change validation, and they are based on mergeable replicated data types and the DEX structured partial order ledger. So now that's for context. Now I'm going to talk about what local first software means and how the network and data layer operates. So in local first software, data is stored locally on the user's computer such that data can be read and written even offline, and the network is asynchronous, and there's an opportunistic synchronization protocol that is available to synchronize data. And in terms of privacy and security, end-to-end encryption is a requirement for such software, and minimizing metadata exposure to third parties. Local first data is enabled by replicated data types that are mergeable. Research in this field started with CRDTs a decade ago. There's been state-based and operation-based variants where operations are commutative. And the more recent mergeable replicated data types and that allow more expressive data structures with merge functions that have access to more context. Operation need not commute, and data types are composable. So I have a slide that's not visible. In terms of transactions, yeah. So these replicated data types can be represented in a directed acyclic graph, and this allows them to be these allow these data stores to be authenticated and immutable, and changes are validated and executed. This has much similarity with DEX structured blockchains used primarily for financial transactions. I will get back to this at the end of the talk. First, I'm going to talk a bit about local first networks and what this means and what they allow. So first, the concept of sovereign domains, that means the network is structured instead of a global overlay, we have smaller subnetworks or sub-overlays, and this allows membership and access control to each domain, where we can store private data and conduct private collaboration. Structuring the network this way is important from privacy and security perspectives, since it offers ethic resilience, since not everyone can join the domains and attack the protocols, but nodes are typically more trusted, and a smaller amount of nodes that we directly collaborate with. And in terms of privacy and security, I would mention that even if we store encrypted data in peer-to-peer systems, when at a later time, in case of a key compromise or cryptographic algorithm compromise, all your data might be publicly accessible. So that's why it's worthwhile also to limit where the data is stored, have control to data locality and the possibility of deletion by sending deletion requests that are honored by the network participants. So this also allows a pluralistic design where different protocols can run in different domains while they can still interoperate by sending external requests from members. Then certain domain members can reply with a certain piece of data that are destined to be shared with authorized external parties. And an important factor in designing such overlays is how we scale these to many domains. And this can be helped by clustering the overlay based on shared domain membership. And to do this, we need a single interdomain overlay that's purpose is to help discover other domains by their IDs and route messages to these and allow joining or sending requests to such domains. And in terms of the data repository design, this is used such that each data repository with their own membership becomes a separate sub-overlay or domain where members collaborate on their data. In the academic research field, the concept of small world interest clause overlays are relevant here, where the interdomain overlay form a small world network where the distance metric is the domain membership similarity. But this is only used for discovery and lookup of domains, just for the initial join or sending occasional requests. But inside the domains, the intradomain protocols that have a membership protocol, like access control and authentication for joining, and a dissemination protocol that is typically a reliable broadcast protocol with causal delivery guarantees when we talk about DEGs. And also typically a storage component where we have an content addressed encrypted block storage for the data of the group. So another concept I would like to mention is the two-tier peer-to-peer networks that differs from typical single-tier networks in that in single-tier networks we have one global network where everyone participates on and everyone's equal. So there's no difference between a node in the data center and a node on a mobile phone. And two-tier networks depart from this, that they are heterogeneous in that there's a stable core network with always-on nodes and many smaller edge networks where users can talk to each other directly on a local network, mesh networks, or even sneakernet USB stick transports. This allows multiple transports with asynchronous delivery requirements and allows mobile light clients to participate in the network without draining all their batteries by just connecting a relay in the core network that they trust for delivering messages correctly, that only have to handle encrypted data forwarding. And in this case also location privacy comes into play, where edge nodes can connect to the core network via anonymized protocols such as Tor or similar anonymization protocols with onion routing or other methods. And here I would like to mention, go back to DEX structured blockchains, which has been used for economic transactions, and there's quite an extensive research in this field. Components of these are mempool for incoming transactions, partial order DAG, a consensus protocol for establishing total order of transactions, execution that executes transactions, mutates state, and garbage collects processed transactions. So the difference between linear blockchains and DAG structured blockchains is that in a DAG we have a partial order independent encoded by the DAG. Independent transactions can be parallelized, and consensus on total order is not always necessary when we have independent transactions that can be processed in parallel. So there are many similarities between fields, between these research fields of blockchain DAG-based protocols and local first protocols for collaboration that are represented in a DAG. However, there are some differences in how the network is laid out, and differences in some requirements. So in a local first setting, we typically do not process financial transactions, but operations on the data. We need data privacy and low latency, so we do not want to outsource the execution of transactions to some node in a data center, but execute them locally or by trusted nodes. In terms of consensus, for mergeable data structures, we do not need to establish a total order. However, a quorum is sufficient for transaction acceptance. But we do need consensus when we want to make a snapshot of the data, and which allows deleting past transactions that we do not need anymore, and to share a data snapshot for publishing, for example. Just to finish, I would like to mention ANOMA, which is a privacy-preserving distributed trust-aware operating system for multi-party intent settling applications. It is concerned with coordination of socio-economic processes dealing with resources, distributed capabilities, and agreement between agents. Others will expand on this in later talks through the coming week. I would just like to mention, okay, missing a slide. I would like to mention two aspects of this. Yes, exactly. I'm finishing in a minute. That are relevant to this research, since the Typhon component of ANOMA is such a DEX-structured blockchain with parallel execution and local, but it doesn't have the local first notions, and the peer-to-peer component of ANOMA is using a sovereign domain peer-to-peer overlay for PubSub and storage. So what I would like to point out here is that when developing local first data stores, it's worthwhile looking at what also the DEX-structured blockchain research has been developing, and there are possibilities for collaboration in developing also local first versions of these protocols. And some links for further reading, and thank you for your attention.